If you look at that little tree they made down there, the probability of X happening, and I think that, you guys see that symbol there where it says, I don't know, forgot how to do this, it's been so long. Where it says X, I think you call that X prime, but what it means is not X. So if this is X, this means not X. So in the tree it says this branch is a 0.4 probability. So what would this branch's probability have to be? 0.6. Because if it either goes here or there, they should add up to 1. These are like the two things that can happen. 0.4 plus 0.6 adds up to 1. And then down below it says y and y prime. That's a 0.3, so that means this would be a 0.7. And this one over here, it's 0.5, so it's 0.5, 0.5. So it's kind of like a 40% chance, 60% chance, 30%. So depending on which branch it goes down on the first one, the odds for the second one change. Okay, so that's one thing that's kind of new. And the other thing that's kind of new is the B question. Let's do the A thing first. What's the probability of X prime happening? Yeah, so if X, the probability of X happening is 0.4, yeah, we kind of already did that. Probability of it not happening is 0.6, yes. Okay, what does B mean? That is the new thing.
Is it multiplied?
No. So we got like a line right there. Does anybody want to guess what it means? Nope. So it means what's the probability of this happening given that X happens? So if you assume X happens, what's the probability of Y prime happening? So in other words, you assume you're already down this branch. So now what's the probability that that's going to happen? 0.7. Large decimal. C. So C would be what's the probability of Y prime happening if given that X prime has already happened. So given that we're already down here, what's the probability that this will happen? 0.5. D. Okay, so this is different. D is what's the probability that X and Y happens. So that means like what's the probability that this and this happens? Multiply. 0.4. We've done fractions in the past, but yeah, 0.4 times 0.3. So that's like an older one. Simultaneous events. 0.4 times 0.3. Anybody know it? 0.12. Remember when you multiply decimals, you just multiply normally and then each decimal place counts towards the decimal place in your answer. So 2 decimal places, 2 decimal places. What's the probability of X prime and Y happening? So the probability that X prime is going to happen, 0.6. And the probability that Y is going to happen after that, that's a Y, is 0.5. So 0.6 times 0.5 is 0.30, 0.3. Okay, now it gets more interesting towards the end here. What's the probability that Y is going to happen? Well, there's 2 ways that we could get to Y, right? Through the X route or the X prime route. So it's like, what's the probability that this will happen or this will happen? Okay, those are not simultaneous events. Those are two different possible outcomes. But we would add the probability of this plus the probability of that. So in other words, we already did this. It was, remember, it was 0.12 for this one and 0.3 for this one.
So 0.2.
So altogether, yeah, if you add those together, you line up the decimals, 0.42, 42% chance. Kind of screwed up with my lettering here. Okay. G. What is the probability of X given that Y happened? Okay, yeah, this is where this lesson gets harder. So we kind of use our previous answers. Out of the point, so this is like the total amount of ways that Y can happen, right? There's like 42% chance that Y could happen. So given that this happened, what's the probability that it came through this route, the X route?
0.12.
Okay, so what you do is it's 0.12 out of 0.42. Okay, only 12% of, or only this 0.12 out of the 0.42 represents the X route. This represents the X prime route. Does that make sense?
No.
Okay, let's say that we did this little experiment 100 times. And 42 of the times we got a Y to come out. Oh, 12 of those times it came through the X route. And 30 of the times, 0.3 is like 0.30. 30 of the times it came through the X prime route. So what percentage of this Y happening came from the X route? And the answer is 12 out of 42, which turns into a different decimal. Does that make sense?
Yeah.
Okay. Anyway, so yeah, that's.
Do you want it as a decimal or?
Yeah, they put 0.286. Yes. So I'm guessing they rounded it to the third decimal place. Does the directions say to do that? No. Yes. Okay. What's probability? So this is kind of the same question, but the other angle. What's the probability that X prime happened given that we got the Y outcome? So this is like the same question, just asked from the other angle. So the X prime contributed 30 out of the 42%. So we would have to do 30 out of 42. Or 0.3 out of 42, I guess.
0.714.
Notice there's a relationship between these two. You guys they add up to 1. Because given that the Y was the outcome, I mean, it had to go through X or X prime, so these have to add up to 1. I think so.
Shoot, it's 1.
Why do you not like chapel? You don't like it eating into your class time?
They have like a 3-person rotation.
Huh?
They have like the guy who jokes about being fat. Nathan. And then, who's the other guy? They have that Mexican guy. Lopez. Lopez.
You get them like once a semester.
He's here a lot.
You're okay. Number 3. Use the tree diagram at the right to find each sum of probabilities. Oh boy. Oh, they're talking about upright, not downright. Okay. Oh no, that's number 2. My bad. Number 3. Probability of A and D happening. Well,
Does it have to be in that order?
huh?
Does it have to be in that order?
Oh, well, you can't get D then A. There's no D on the first round. Anyways, probability of A, D happening is 0.5 times 0.1, which is like 0.05.
Wait, what?
Remember, when you multiply decimals, each decimal place is represented in the answer. The reason this only had one decimal place is because I dropped off the 0. 0.2 is the same thing as 0.30. Okay. Plus the probability of A and E would be 0.5 times 0.9, 0.45. Add them together, 0.50. When you add, you just line the decimal places up. Okay, probability of B, I don't know why they're asking these, kind of easy. Probability of B and D, 0.4 times 0.7, what would that be? 0.28, there you go. Now we're back on the right track.
Good.
Probability of B and E, 0.4 times 0.3. Add them together.
You got the next one.
Probability of C and D. So probability of C, they didn't list it, but what would the probability of C have to be? 0.1. Oh, well, they didn't list the D and E options because why?
Because they're
Okay. Because if you look at the two things they listed, what's the probability of C and D happening and C and E happening? So basically they're saying we're going through C and then it goes here or it goes here. Okay, so the probability of this and this together is basically the same as the probability of C happening. Does that make sense? Because there's a 10% chance it'll go to C, and then after that it could go to D or E, but basically they're just saying if you go CD or CE, that's basically like saying you're going through C. The probability of going through C is 0.1, because we've got 0.1 left out of these 30. They should add up to 1. All the probabilities together should add up to 1, because those are the only 3 things that could happen, A, B, or C.
For 2 days.
I feel like not.
No time. Shoot.
Shoot.
I was hoping to finish. Dang it, bro.
If we're only as responsible and diligent as you, Trey. We can only dream. Jar A contains 2 red balls and 3 white balls. Jar B contains 4 red and 1 white. A coin is tossed. If it shows heads, a ball is randomly picked from jar A. If it shows tails, balls are randomly picked from jar B. Draw a tree diagram showing the probabilities of each jar and then the probabilities of picking a red or ball or white ball. Alright, did you guys follow that when I read it?
Yes.
What's the first thing that's going to happen?
Coin is tossed.
Right. Heads or tails. And then what would the probability of the heads or tails be?
50-50.
50. I guess we're
Still
going.
don't believe it, but
How do you not? Which one do you think's more likely?
probably heads. Actually, no tails, because heads has like the picture of the
Okay,
guy.
get out.
Tails is actually 0.4998.
Just tree.
I've read books.
Okay. Oh yeah. And then we're going red and white for the ball colors. Okay. What's the probability in the first jar? This will be my jar A. Heads goes with A. Yeah.
Where's she been? Is she just really late?
She woke up
Oh, that's Ayla.
That's crazy.
Oh, was that Ayla?
Yeah.
Pre-Calc.
That's master club.
She's like counting clock. We just got the ring camera, so it says some of your photos. I click on it, and you see you guys around. Shut
She
up,
literally swore you didn't have a camera.
We just got them, bro.
Alex, I got so scared.
They make your voice kind of liars.
And then you see like the she was too scared to ring your doorbell because she didn't know why it was asleep. I was like, the kids are definitely asleep.
They weren't. I gave the ice cream to Jasper.
Which one did Jasper, which one did he eat? The big one?
Yeah.
That was mine. We couldn't think of anything. So I just said, give me the ice cream.
Alright, so if we're in jar, if we flip to heads and we're in jar A, what's the probability that we're gonna get a red? Shh.
2 to 3.
2, no,
2 to 5.
2 out of 5. Which, as a decimal, 2 out of 5, 0.4. So what's the probability we get a white? 0.6. If we're in the second jar, we flip to tails, what's the probability we get a red? 0.8, which means it's 0.2 to get a white. Alright, and then B, find the probability of picking a red ball.
Do you multiply 0.4 times 0.8?
No. So getting a red ball could happen 2 ways, right? We could flip a heads and then choose a red, or we could flip a tails and choose a red. So how would we find those probabilities? Okay. What's the probability of heads red? 0.2. 0.5 times 0.4. Okay. What's the probability of getting tails red? 0.4. What's the probability that that or that will happen? 0.6. Okay, if you have 2 separate things that could happen, you just add them together. You have 60% chance of getting red. Okay. C. If a red ball is picked, okay, this goes back to the tricky one on number 1. If we know we got a red, what's the probability that it came from jar A?
0.2 or 0.6.
Okay, yeah. So jar A was the tails flip. I could have called this A, or the heads flip, sorry. I could have called this jar A also, the heads flip. This is jar B over here, tails flip. So yeah, out of the 0.6, 0.2 of that was from jar A. That was this route. So you do 0.2 out of 0.6. 1/3, what's 1/3 of the decimal, you guys know? 0.3 repeating. They probably just put that because they've been going to like 3 decimal places, yeah. I guess correctly. Yeah, that's kind of a new trickiness, so yeah. We'll try it. Maybe I'll just do number 1 with you. It doesn't take that long. Number 7. Machine A produces 60% of the ball bearings manufactured by a factory, and B produces the rest. 5% of machines A ball bearings fail to have the required precision, and 2% of machine B bearings fail. So A produces more, but it fails more often. All right. Draw a tree diagram. So how should I label my branches here?
A and B.
Machine A, machine B. Okay, then given that we got a machine A ball bearing, what are my other 2 categories here?
Fail, not fail.
We could do pass fail. Or fail, not fail.
Let's just do pass fail.
Okay, so what's the probability that it came from machine A? 60%, so 0.6, that means 0.4 to machine B. What's the probability, it said the probability of fail on machine A?
0.05.
5%, 0.05, so what's the probability that it passes? 95. And B, didn't it say 2% fail? Whoops. Did it say 2%?
Yeah.
Okay, so 2% fail rate and 98% pass. Alright. What percent of the bearings fail to have the required precision? So what are they asking? They're asking how many come from here or here, right? How many fail? So it's what percentage are in this route or what percentage are over here? So it's kind of like B from number 5. So the percent from machine A that fail is 0.6 times 0.05, should be 0.03. And the percent that comes from machine B would be 0.4 times 0.02, which would be 0.008. Now what do I do with these two?
Add them together.
Yeah, add them together. You guys know what that would be? 0.03 plus 0.008?
0.038.
Yeah, the decimals just line up, so it's 0.038. That would be. So about 3.8%. Did they ask for a percent or did they? Oh, they did. Okay. What's that as a percent?
3.8%.
3.8%. So, alright. I think these last two are the only ones that use percentages instead of just pure decimals. Actually, C asks for decimals, so just B. Alright, C. If a bearing is inspected, okay, this is like C from the last one. This is like G and H from number 1. If a bearing is inspected and fails to have the required precision, what's the probability that it was from machine A? So, the overall fail percentage was 0.038, right?
Mm-hmm.
So that's like the total. How much of that was from machine A? 0.03. So we're doing 0.03 out of the 0.38 in total. And just divide that. Okay. Does anybody want to request me explain those last problems again?
I got B.
Huh?
I got B.
Well, C is what I'm asking about.
Uh,
I mean, like, it's always the last problem. It's like C on 5, G and H on 1. It'll be like C on 8.
yeah, can you explain this one again?
Okay, so it's using the previous stuff because it says, given that we have a failed ball bearing, what's the probability that it came from machine A? So basically we're using this. You want the target group, which is from machine A, out of the total group. So the total group is represented by when we found how many failed ball bearings there were. Okay, this line BS, what percentage of ball bearings are going to fail? Okay, so we kind of found the total percentage of ball bearings that fail. 0.03, well, 3.8% or 0.038. So that goes down here. And the target, they said, given that we got a failed ball bearing, what percentage of the, how did they say it? Probability. What's the probability that it came from machine A? So, out of this 0.038, 0.008 came from machine B, 0.03 came from machine A. So you do the target, which is machine A, out of the total. Machine A's failures out of the total failures.
Okay. Makes more sense.
It is. It's confusing, but if you see the pattern, yeah. Okay, Lydia, let's do number 1, then I'll let you cut you loose.